Yeah, thank you, Sean, for introducing me, and as well as inviting me to give a talk in this seminar. It is my pleasure to uh, be be here and give a talk. So this talk is gonna be, in a nutshell, this is gonna be using a intentional quantified modal logic, of which Sean is a big fan. And then I will add the epistemic logic on top of it. So that's the nutshell. But let me start with an introduction. Let me see. Ooh, sorry, just give me a moment. Let me start with an introduction in which I use some example and explain what this talk is about, what my project is. So the example involves several crystals and an agent or a cognizer S. Suppose S knows that S owns a crystal, but she doesn't know whether it is soluble or not. We may draw a picture like this to indicate the two epistemic possibilities. And then on top of this, we may even draw a truth table with these sentences indicating, depending on, to describe the situation, indicating whether the crystal is in water or is dissolved or not. And then we number the rows 1, 2, 3, 4, and they apply to the picture like this. So the cognizer S knows, does not know whether the crystal is soluble or not, can be expressed by this dashed circle indicating that the cognizer knows that the actual situation, actual possible world is inside this circle, but which of these two worlds she doesn't know. Okay. Then this picture essentially gives a possible world semantics of the epistemic state of S, in which we have 4 possible worlds. In the worlds within the red partition, we have this sentence true saying that the crystal is dissolved if and only if it is in water. So using the possible world semantics for the box operator using the accessibility of this partition, you get this box version of the sentence is true, namely, in other words, it is necessary that the crystal is dissolved if and only if in water. On the other hand, in the green partition, the crystal is never dissolved anywhere in those two possible worlds within the partition. Therefore, it is not. It is necessarily false that the crystal is dissolved. So this is a long way of expressing this modal property of the crystal of whether it is soluble or not. And then on top of this, we have this dashed circle indicating that the agent or cognizer knows that the actual situation is inside this circle, but not which of those two worlds she doesn't know. So this sentence saying that S knows that. So the agent cognizer knows that the crystal is not dissolved because in both of the worlds within this circle, this sentence dissolved is false. But on the other hand, the cognizer doesn't know that this is the case because she cannot distinguish whether she is in the red world or green world. Okay. So this is the gist of how necessity and knowledge or belief interact in possible world semantics for propositional modal logic. And for instance, the dynamic epistemic logic is a version of this, and then you can do all sorts of nice things. But this is propositional logic, propositional modal logic, and my talk today is about something swept under the rug here when we take seriously the fact that the solubility is a modal property of a things rather than just a propositional fact. So to show that to the picture, so there are two crystals A and B, and the cognizer knows that one is soluble while the other is not, but she does not know which is soluble. Okay, so this is the picture like before. But what is a kind of something that is doing a conceptually heavy role here is these arrows giving sort of a what we may call trans-world identity of those crystals, because if you take the different combinations of trans-world identification, then look, the case on the left and the case on the right are both saying that A is soluble. I mean, if you put the crystals in the ball, A will disappear, B will stay. So look, this would mean that the cognizer would know that A is soluble and B is not. So okay, so to represent the epistemic situation, it is essential to have rather than this, we need to have this, or else we will be representing something entirely different. Then the point of the trans-world identity, the notion of trans-world identity is to make sure that we can represent things in a way we want to. And then, any semantics of quantified modal logic like Kripke's come with such a gadget in their semantics. So far, that's nice. But then in some semantics, like Kripke's, the following would cause a bit of a trouble. So suppose that the is used to own a crystal, but it was stolen some time ago. Now she knows that this crystal C came here. It's now one of A and B, but the problem is that she doesn't know which one is C. Okay, so there are two epistemic possibilities. One is on the left, one is on the right, and then you have a identity between those among those three crystals in each possibility. But if you throw in, for instance, Kripke's idea of trans-world identity given in his own in his way of semantics, then well, look, those names A, B, C, they refer to things rigidly, therefore A equals A equals C here, C equals C, well, C equals B here, and B equals D. So look, from this, you are, okay, deriving within the semantics that, look, okay, something is wrong. Okay, so far, it's something is wrong. But the point is that so trans-world identity is needed to let the second case, to represent something like this. But the way trans-world identity is implemented in, for instance, Kripke's semantics, causes this trouble. So you cannot really combine those two cases together as in the following example. S knows that one of A and B is C, like before, but S also knows that C is not soluble. Therefore, it's a reasonable thing for S to infer that A equals C if B is soluble, but B equals C if A is soluble. Sure, but there are notions of transworld identity needed to represent one part of this scenario, but that's going to destroy another aspect of this scenario. So sort of the guiding question of this talk is, okay, so how can we model this situation like this semantically? Okay, so this is the first question that we want to that I want to answer. But of course, you know, modeling things is kind of easy. I mean, yeah, sure. I mean, we can cook up any weak semantics in which we can express everything, anything. So we need a little bit more focused questions to as a kind of a more higher standard or some other criteria of what our model should do. So let me explain them a bit. So as we have just seen, Kripke's semantics, I mean, we are going to see in a more detail, but Kripke's semantics cannot model cognizer's ignorance or identity. But on the I mean, so one conclusion, one consequence of that, as Kripke draws, or not draws. I mean, which is a consequence or not? Let's put that aside. But the point is that they look, this identity of individuals is a fact that is necessary but a posteriori. But as long as we stick to Kripke's semantics, we cannot express a situation like this. Therefore, so the question is, how can we or how can the necessary a posteriori be a posteriori? How can we model that? How can we model a posteriority of such a metaphysical fact? And it's not just about Kripke's semantics. There's other frameworks of approaches to the semantics of quantified modal logic. For instance, there's a notion, I mean, there's a counterpart theory, and people use the ideas of sortal to as something as some context something that gives a criteria of identity across different worlds. But now then the question arises, for instance, whether some given concept like elementary particles, that kind of thing, whether that is a sortal or not, in the way giving a criterion of identity or not, that's not that's a something we have to find using physics and so on. So in a way, that's a substantive fact. It's not just a matter of logic. But look, as long as I'm going to sort of explain that, as long as we stick to the previous semantics, we cannot treat such a question whether elementary particles are, I mean, that concept is a sortal or not. It cannot be a posteriori. We cannot express that as a posteriori. So we need a picture in which we can explain how cognizers can arrive at such principles by some reasoning. I mean, the point will be even bigger than just, you know, us philosophers expressing some artificial agents or cognizers, but philosophers ourselves arrive at metaphysical principles by certain reasoning. Look, philosophers of physics, I mean, they are talking about whether elementary particles are going to give a criteria of identity or not, right? So they use some reasoning. But once we ask quantified modal logicians, okay, look, this is the result of our philosophical analysis about this concept, whether it is sortal or not, then logicians' semantics reflect the end results as part of the definition of their semantics. But then the question I have is, okay, so what about the logic that those philosophers of physics just used in their reasoning to arrive at the conclusion whether, with respect to whether elementary particles are solid or not? So, so my goal will be to provide a framework of semantics in which these metaphysical principles, whether identity of individuals or whether sortals are such and such, whether given concept is a sortal such and such, these are substantive facts that can be a conclusion, or I mean even sort of a some or premises of philosophical or general argument. Let me go back to the previous example to indicate what I really mean by using. Well, I mean, one of the things I mean by using is this. So this is the inference that this is the previous, this sort of puzzling example that I was talking about. S knows that one of A and B is C. S knows that C is not soluble. Therefore, S infers that the A equals C if B is soluble. But if A is soluble, then the other guy, B, must be C. Okay, so one question I wanted to ask is, how can cognizers learn the identity of crystals, which are necessary a posteriori? But they, this is kind of an interesting inference that the cognizer is making, because if you just write down the cognizer's inference in first order logic terms, then yeah, this is a valid argument in first order logic. So okay, so now the problem is, now you may think, isn't it just the cognizer using first order logic? One goal of this talk that I will do in the end of this talk is that to show that, look, this inference is not valid. This is not a valid argument. This is an invalid argument. There must be some metaphysical principles behind this inference to let this inference go, and that's how cognizers use metaphysical principles. That's how cognizers must use that principle. I mean, that's why those metaphysical principles must be a substantive fact rather than just a matter of logic built into the semantics. Okay, so this is the question: how do cognizers use metaphysical principles in such reasoning? So the goals of this talk is to give a logic and semantics that treat metaphysical principles as substantive facts rather than just matters of logic built into the definition of semantics, and moreover that cognizers can use, philosophers are using in modal reasoning and theorizing. So these are the goals, and the outline of the talk will be something like reviewing extensional logic by Kripke and Lewis, counterpart theory, and so on. The previous approaches, I explain why they do not meet my provide the things I want. And then I will give a brief review of intensional logic. And then I will show that, look, yeah, intensional logic can provide what I wanted. Okay. All right. So that's the intro part of the talk. I hope the motivation or the project is at least clear. Okay, great. Yeah. So let me give a brief review of the previous approaches by Kripke and counterpart theorists and so on, and I will sort of explain a little bit more what is unsatisfactory with those previous approaches. I'm not saying that they are philosophically incorrect. That's an important point. I mean, my point is not that they get philosophy wrong. My point is that I have, as a logician, I have certain goal, and they do not meet they do not give me what I want. Okay. So that's with that disclaimer. Let me go on to the next slide. So here's a Kripke's semantics, how it works in a very brief sketch of it. So in Kripke's semantics for quantified modal logic, you have a set of possible worlds down here, and then the set of individuals, possible individuals up here. And then you're going to take kind of a Cartesian product of them, like this. You're going to take a like world individual pairs, and then you assign extensions to predicates in each world. So you're going to say that, hey, these things are red in this world, but in this world, only these things are red, and here in this world, only this thing is red, and so on. Yeah. Then you're going to give the usual semantics for such a sentence by us asking, okay, so I mean, we're going to test whether this sentence is true or not. So there is a something that is necessarily red. Okay. So actually, this turns out true in every world, because in this world, hey, look at the A. A in here is not just red, but it's red everywhere. Therefore, A is necessarily red. And therefore, there is a something that is necessarily red in W1, W2, W3. I mean, for the same reason. Okay, so what is the sort of the upshot is that, look, individual variables X right now we just used is what the Kripke calls a rigid designator. It refers to a thing in the domain rather than those points. Okay, so this is going to pick up a so X is ranges over these things in the domain. Therefore, this whenever we say X is blah 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 in each world, you are going to talk about this how to call it, this sort of a cross section. Okay, and for the same and then Kripke also gives this argument that the individual constants or names must be rigid designators too. So when you introduce a name like alpha, then alpha is going to refer to pick up one of the things from the domain here. Okay, but on the other hand, his point, Kripke's point, is that on the other hand, definite descriptions are not rigid. So when you say the number of planets, then this expression about individuals are not going to pick up a thing from this domain, but it is going to pick up for each world it is going to pick up one thing. Okay, so that's how you are going to talk about say things like the number of planets is necessarily bigger than 7 or not. There are two ways to, Deraye and Dedicto reading and so on. Okay, so without going into too much detail, what we want to observe is that there are not so the reference is not very uniform here. Individual variables and constants are rigid designators. And then these definite descriptions, those are not rigid designators. And this is a matter of syntax. You just look at the syntax, and then whether it is rigid or not is just determined by the syntax. It's a matter of logic. If you take a name within this semantics and then say that they are, hey, this may refer to different things, and then yeah, you're making a logical mistake. Anyway, so that's given this, one consequence is Okay, one consequence of this semantic definition of semantics is that this inference, if this principle that if x equals y, then it is necessarily, they are necessarily identical, x and y. Therefore, if Hesperus is Phosphorus, then it is a necessary truth. It is a necessary, they are necessarily identical. That's an immediate consequence of the the definition of the semantics. So once the semantics is given, then the explanation is extremely easy because look, take a x and y, or maybe Hesperus and the Phosphorus. Whether we it's then we it's whether, okay, so Hesperus may be this, and Phosphorus, you may pick this or you may pick this, and depending on whether you pick the same thing or not, that the choice is determines the truth of this identity predicate. Therefore, therefore, once you chose the same thing, then it's the same. They are the same throughout all the possible worlds. Otherwise, no. I mean, they are different everywhere. Sure. Okay, that's a very easy, quick explanation. Two problems. One is that okay, smaller thing is that this semantics cannot model the sentence, the statement like, I don't know whether Hesperus equals Phosphorus or not, because if you take I mean, let's go back to this picture of possible worlds. And in the case of a solubility of crystals, there was nothing in the semantics that prevented us from modeling a uncertainty or ignorance of the cognizer. But when you throw in this semantic definition of the semantics into the picture, then you can't have a situation like this. I mean, in those red worlds, H equals P, green worlds, H is not P, because if you choose H and P to refer to the same thing in the given model, then it refers to the same thing throughout the entire world, the entire model. If a model assigns different things from the domain to these two names, then yeah, they are different things across all the possible worlds. Therefore, you cannot throw in a model, construct a model like this. Okay, so that's a smaller problem. Well, okay, I don't know which is smaller, but that's one problem. The other problem is this. This explanation of why this is the case, why x equals y implies necessarily, its necessity. Sure, this is one explanation once the semantics is given, but that's not Kripke's argument for the necessity of identity of individuals. He gave a much more substantive philosophical argument for this principle. And then after that, he built up, given that explanation, that justifies this technical formal makeup of his semantics. But this semantics is not his argument for the necessity of a necessary aposteriority of the identity of individuals. So there's a significant discrepancy between the philosophical argument Kripke gave and the logic he used in giving that conclusion, and the logic given by Kripke's semantics. So my point is that, look, this semantics reflects the end result of Kripke's analysis. This is not the semantics for the logic that Kripke used in the whole book. Okay, so this is the second problem with the semantics. Look, this principle, metaphysical principle that Kripke arrived at after after lengthy philosophical argument, this is treated as a matter of logic in the semantics. That's why we want something. That's why this is not really giving me what I want, namely a semantics for a logic that philosophers and cognizers use in metaphysical reasoning and theorizing. Okay. All right. So, and this is not just about a Kripke. I'm basically in this talk, I'm sort of taking Kripke as the sort of the archetype of all all the previous approaches. But I mean, the same thing goes with, for instance, counterpart theories as well. So in counterpart theory, you take a worlds, and each different world has a different domains of individuals, of things that exist in that world. And then you're going to give a trans-world identity in terms of a counterpart relation between those supposedly different things from different worlds. Okay. Then there are extension or more generalization of these original original semantics by Lewis, by Gibbard, or slightly more recently Graf Farah. For instance, the Gibbard example is that they look. Sometimes there are identities that are coincidental. Like in this world, you may have two things: Goliath, the statue, and Lumpo, the lump of clay. And in this world, it happens to be the case that the Goliath is made of this lump of clay. Therefore, Goliath equals Lumpo. But it could have been otherwise. So, so the point is that they are. So the point of the example is that they are. There may be, I mean, this thing, Goliath, the statue, namely the lump of clay, identical in this world, may have different identities, trans-world identities. One Quay Goliath and the other Quay Lumpo. Okay, fine. I mean, that's whether you agree or not, whether I agree or not. Okay, that's a respectable philosophical claim. And then so the other philosophical logicians give like formalization of this idea using sortals as a sort of a tool to give criteria of identity and sameness or counterparthood across the different possible worlds. And then, yeah, sure. I mean, Goliath has a this trans-world identity, Quay statue, because statue is a sortal, or Lumpo has another criteria of identity because Lumpo is a clay and clay is a sortal, and so on. Okay. Now, again, my criticism is again twofold. One, okay, we don't know. I mean, so okay, so as I said, what particular, I mean, given a concept, whether that is a sortal or not, can be a posteriori fact, like in the case of elementary particles. And so the we need a semantic framework in which a cognizer may come to learn that fact, even if elementary particles are not sortal. Or two, once we get that, that's, I mean, all these previous approaches incorporated the fact that, for instance, a clay is a sortal as part of the definition of the semantics. It's part of the model. So whenever you, okay, so you cannot express cognizers ignorance whether regarding whether clay is a sortal or not. But again, this our modal reasoning, our modal theorizing, the logic given in this setting is not the logic we use in arriving at these metaphysical principles. Okay. All right. So that's the conclusion. So this is the part one. So the conclusion is this. Okay. Yeah. I'm just Okay, so it's written there. So this is just repeating myself, but yeah. So the point is that the metaphysical principles concerning cross-world references are treated as matters of logic built into the definition of semantics, rather than substantive facts we may come to realize we may learn, and so on. Okay, so nothing can be expressed as necessary a posteriori in this setting. Okay, so this is sort of the not the criticism as or not the criticism of theirs as philosophical positions. They may get the metaphysics right, but that's not the thing I'm talking about. The point is that we cannot use this end result of their potentially correct philosophical analysis as the semantic framework for the logic we use to arrive at this conclusion. Okay. All right. So let me get to the intentional logic part, in which I'm going to sort of so this is a one approach. Previous approaches, and this is another approach. I mean, existing approach. But the conclusion of this talk is that this framework of intentional quantified logic by Bresson and Belknap is going to provide me with what I want. So here is this part is just a review of what the semantics is like. So in this framework, it's you can kind of consider this as as a semantic structure. This looks pretty much like a counterpart theory. So you have a set of worlds, and then each world has a domain of individuals. I mean, not necessarily disjoint. So it doesn't have to be disjoint or anything like that. But the point is that our picture has two parts. One part and another family of things that exist in each world. And then individual intention is pretty much in a Carnap way. Those are functions or partial functions from those worlds to those domains of individuals. Okay, so this red individual, red is an individual intention. That is a function that given a world, it assigns something in that world as the extension of that intention in that world, and so on. And then this beta is like that too, except that they are here in world W5. Okay, so alpha of W, for instance, here you have a alpha of W1 here. That is a alpha's extension at this world. This beta doesn't have a extension in W5, so it's sort of lacking an extension. It doesn't exist in W5. Okay, so those are the individual intentions, and I'm going to write a pi for the set or family of all these individual intentions. And then the difference, so unlike in the previous extensional logic, or I say Kripke's logic, Kripke's semantics, we interpret all the individual terms in terms of intentions. So variables range over the intentional individual intentions, and constants are interpreted by individual intentions. Functions, function symbols are interpreted by functions among individual intentions. So it takes individual intentions as inputs, and then spits out individual intention, and this individual intention may have different extensions in different worlds. So the point of, well, it's a little bit of too much, maybe too much detail, but for instance, Aristotle's, think of two definite descriptions of function symbols. So function symbol, yeah, think of function symbol. The youngest offspring alive. Yeah, and then plug in, say, two different names like Aristotle and John F. Kennedy or something like that. Then they have different intentions as inputs, so they may spit out different extensions, even though those two inputs, Aristotle and John F. Kennedy, may no longer exist in the current world. Okay, right. So that's too much of a detail. Okay, so far is the how to interpret individual intentions. Oh, no, sorry, individual terms. Now, we are going to next order of business is to interpret the predicates, but predicates are also generally predicates about individual sort of they generally denote properties of individual intentions. So in terms of the picture, it is a more useful to redraw this picture based on those dots, these dots into this picture, in which you get intentions as the basic things. Okay, and then we are going to have among these intentions, sometimes these intentions, for instance, alpha and beta, may have the same extension in world W3, for instance. Therefore, this and this, I hope you can kind of see that this and this are two different pictures of the same situation. Okay, all right. Now, given this, you are going to assign extensions, not extensions, but sort of interpretations of a, yeah, okay. So this is generally, this may, this and this may, here you may have an intersecting, individual intentions intersecting, having the same extensions. These are where individual intentions have no extension in the world W5 and so on. Okay. Now, given this, predicates are interpreted by, just a sort of how to call this? This is not an extension, but the picture would be easier to see. So predicates are interpreted by just assigning to each individual intention the extent of the set of worlds in which that intention satisfies the predicate. So for instance, look at this green and the red, and then beta is green. This beta intention beta is green in W2, W3, W2, W3, W4, W5, but it is not in W1. Alpha equals beta is true in okay, so this is and then on top of this, the identity is interpreted by extensional identity of individual intentions. So here, alpha equals beta is not generally true, but when you look at this possible world W3, then they happen to have the same extension. Okay, and then existential statement, existential quantifier. No, sorry, this is an existential. The predicate of existence is given by X is not this thing that sort of gives a that says that the X does. So this star is a some artificial element that says that the value is undefined. So X exists can be written this way, and then predication is generally intentional. Although it can be extensional. Okay. Now, so I hope the picture kind of speaks on behalf of on my behalf. Okay. So then the quantifiers is going to say some X is blah blah blah, or so you can kind of read it as either So you can sort of have two quantifiers, some x's, blah, 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 in the sense of going through all the individuals, including asterisk, or excluding asterisk. You can choose. And modalities have in every world, in at least in Bresson-Belknap setting. Okay, there's no accessibility in their framework, so box just means in every world. And then you can, on top of this, you can kind of introduce a slightly different modality, saying that if X exists, then X satisfies such and such property. That's a slightly different thing than the original definition of box, and so on. Okay, so good. And then, so the point is that all the individual terms are interpreted by individual intentions uniformly. So there's no distinction between variables, names, and definite descriptions. So for instance, the case of the number of planets, the de Rey and de Dicto end up with quite a different behavior here, because here there's a number 8 that happens to be the number of planets in this world, and that is necessarily bigger than 7 Quay 8. So if you are talking about the individual intention 8, then yes, that is necessarily bigger than another individual intention called 7. But if you take another individual intention, namely the number of planets, then that's not necessarily bigger than 7. Quay the number of planets. So the drawback is that, okay, so there's no de Rey and de Dicto distinction here, because whenever you sort of refer to necessary property, then there's no Rey, there's no thing in this picture, because you're always talking about individual intention. So that may look like a problem, which turns out not to be a problem, as I will explain in a few minutes. So that's one observation for the moment. And then, given this, the easy solution to the original puzzle I had of, hey, can we know? Can we model the cognizer's ignorance in terms of whether alpha, whether gamma, whether crystal gamma is alpha or crystal gamma is beta? Yeah, the cognizer's ignorance can be just simply modeled by this picture. So this is a one easy way out. Sure, I mean anything. I mean this is a very general framework of semantics. So yeah, sure, anything can be expressed, anything can be modeled. Sort of good. So the conclusion is that in this intensional logic, all the singular terms, individual terms, predicates, quantifiers are treated as uniformly intentional, except maybe the extensional identity. But the point is that okay, so far one criterion down, namely just allowing us to model the ignorance of the cognizers with respect to the identity of individuals. Okay, so far so good, I hope. Anyways, sorry. So far I'm saying kind of like a weak thing. Okay, look, this is a general framework, so we can model what we wanted to model. What we wanted to be consistent is now consistent in this weak semantics. Sure. Okay, but I want to say a much stronger thing about this proposal, namely that in this semantics we actually have a lot of expressive power with which we can model cognizers learning and using metaphysical principles inside this logic. So let me get to the expressive power of intentional logic of the kind I was talking about. So let's get back to the Goliath and Lumpel. Okay, so this is just an example. So let me be quick. So there are two ways of saying that the Goliath is a statue and not clay. Sorry, saying that the Goliath is clay. One is that Goliath. So one is a sorry, maybe this is better. So when we say that the Goliath is clay, Lumpel is clay as I mean, it's as a matter of in the sortal sense. So Lumpel's identity is given by the statue, sorry, by the sortal clay. On the other hand, Goliath is happens to be made of clay, but it may not be a clay in other possible worlds. Okay. So so here we have two senses of sortal way and non-sortal way of applying the word clay, and that's something we can express. Those two meanings of is clay can be expressed by this intentional logic in this way. So the general point is that the properties of properties, for instance, this happens to be clay, even though as a matter of sortal, it cannot be. It may be otherwise, but it is made. It happens to be clay. That sort of thing. Those are properties of properties can be defined using this intentional logic. That's the point. And so this is one example, but the more crucial example is the following. So there is this. So in this slide, I'm going to give the most crucial idea in this talk. One, so let me define it step by step. First, let's say that this property phi is modally constant. To say by which to mean that a given for any x, phi is modally constant means that they are given anything x satisfies it necessarily or doesn't satisfy it. I mean, necessarily fails to satisfy it. Okay, so in this picture, red and green, those are modally constant in this picture. Okay. Two, x and y are parallel to mean that they are. So this is not about the property of properties, but this is property of, or the relationship between two individual intentions. They are parallel if and only if either they are always the same within the accessibility relation, or they differ as long as they exist. Okay. Now, given those two, I'm going to define the notion of, well, not my definition, but this is Bresson's idea, is that we can introduce the absoluteness of a given property as follows. So phi is absolute even only if it is modally constant and moreover modally separated in the sense that whenever x and y satisfy this absolute property, they must be parallel. Okay, so this is the idea. This is the definition, but the idea will be simpler with the following picture. So bear with me. So, okay, so let's introduce one individual sort of a individual intention. Now let's assume that this satisfies a so this is a one individual intention. Now there's another individual intention, and by saying that they are parallel, it means that they never intersect as long as they exist. And there's another intention. So the parallelism between those individual intentions means that they are always they never intersect in this picture. Okay, and then the absoluteness means that for instance, x is a number means that it's whenever those individual intentions satisfy this is a number, absolute property is a number, then it means that whenever you take those two things, for instance, this individual intention and this individual intention, they never intersect with each other. Quay numbers. So the point is that these absolute properties are going to give a criterion of identity. So if 6 and 7 are numbers in this in this absolute sense, then they are either identical throughout all the possible worlds or all the accessible worlds, or they are different throughout all the accessible worlds. On the other hand, the number of planets, this intention is not a number in this absolute sense. That allows this thing to intersect with 8 in one world, intersect with 9 in another world, intersect with 6 in another world, and so on. Okay. All right. So let me. So So this framework, on the one hand, gives a handle on the Dirac-Dicto distinction. Because whenever you say that so this is the statement saying that there is a number that is the number of planets and they are bigger than 7. You can introduce the box operator in two different positions, here and here. Yeah, and then this is going to give a sort of a Dirac reading, because here you are picking up a individual intention x that is a number in the absolute sense. So you are talking about this number as Quay number in this way. So this number x Quay number is necessarily bigger than 7. So this is this is a Bresson's handle of Dirac, how to deal with Dirac modality in using a absoluteness. Okay, so good. So this is sort of the review of the notion of absoluteness. Okay, I hope. So yeah, okay. So now. So the most important part of my talk, why the heck this was needed to provide, to give me, why this gives me what I wanted. Okay, so I'm going to so in Bresson and Belknap framework, there was no accessibility relation, but now I'm throwing in sort of an accessibility relation in, and then the following is what happens. So let me show this to you. So one is this. Using this, my sort of a general point is that using this framework, we can recover the logic theory distinction in back in quantified modal logic. So usually people call their model, quantified model logic. But my point is that, look, Kripke's model logic is actually a theory, metaphysical theory, and his semantic models of semantics reflects his theory. That's the point of this slide. So let me sort of proceed. So the point is that, yeah, this summarizes. So using this logic, we can axiomatize Kripke's semantics as a theory on top of the intensional logic. The detail is like this. So we are going to throw in a absolute property is a thing using axioms like, okay, T is absolute. And then every individual intention has another individual intention or another sort of a thing intention. Yeah. So the number of planets itself is not absolute. Is not number. I mean, it's not absolutely a number, or maybe absolutely not a thing, but it still has some thing intention. Yeah, this is the picture. So in the case of numbers, these are all these red lines were all numbers, and then a blue intention is not a thing intention. It's say number of planets. So when we do the Dirac modality, we are not going to be talking about a necessary property of this individual intention, but at least in each world, this individual intention blue has the same extension as some individual intention red here, and this red is an absolute. Is a thing intention. Okay, and then given this in terms of this, Kripke is a sort of a principle that all the names are rigid designators can be paraphrased as saying that, look, all names are thing intentions. Those names are, referred to as individual intentions, and those individual intentions are thing intentions. Okay. Okay. So the picture kind of makes it clear, right? We in the Kripke's semantics, we started with the W here and D here, and then this sort of a plane was provided as a Cartesian product of this axis and that axis. Sure, we kind of constructing kind of a similar thing because we because of these axioms, every point in this plane has a thing intention. So if we draw them in a parallel way, you actually get you can kind of reconstruct the D here as the set of thing intentions. Okay. Then you can translate Kripke's language into ours by saying that the Kripke's for all can be translated as for all thing intention whose extension exists in the current world, blah blah blah. Or the box operator can be now treated as a kind of a Dirac thing. So there is a thing intention for all x. Sorry, x satisfies phi necessarily means that there's a thing intention y, and y satisfies a phi necessarily. It's thing intention y that coincides with x, and this y satisfies phi necessarily. And then for each sort of a basic primitive predicate, we can sort of introduce an axiom saying that it is essentially extensional, blah blah blah. Anyway, so the point is that this translation allows us to prove the theorem that, look, this system, this theory added on top of this intensional logic proves the translation of the original Kripke's logic, even only if it is provable in the original is provable in Kripke's logic. So it's pretty much like a translation result. So the point is that, look, we can translate Kripke's logic as a theory on top of the intensional modal logic. Okay, so this is a one technical observation that, look, intensional logic is not just general, but that is expressive enough to sort of to express a what previous approaches called logic, quantified modal logic, as actually as a theory. So recovering kind of a logic theory distinction in the realm of a quantified modal logic. Okay, this is nice. I think you agree that this is technically a nice result, but it's not just technically nice, because look, now that this is a theory on top of logic, therefore these theories are something that the cognizer can know or can does not know. I mean, it's possible for a cognizer to know this like Kripke's theory of metaphysics, or the cognizer may not know it. So that's the point about this. So for instance, this is the picture. Now how can we sort of express? So this slide is not the main part. So this slide is going to describe what our model will be for the situation in which the cognizer doesn't know whether a gamma is alpha or gamma is beta. Okay, so this is the picture, and if we introduce a sort of this kind of metaphysical partition, in which here, for instance, right. So here there are other possibilities. But if a Kripke is right, for instance, if Kripke is right that these identities are necessary, identity and non-identity are necessary, then sure, this must be the case, and that can be modeled as partitions in which, in the top partition, yes, green and red are identical and blue are not identical. In the bottom partition here, green is identical to blue and red is not identical to them. Yeah, and then across these partitions, there's the ignorance of the cognizers is expressed by this picture in which a green, so the cognizer doesn't know whether the situation is W1 or the actual world is W1 or the actual world is W2. So she cannot know whether this is the case or this is the case. Okay, so this is the sort of the picture or model of this model in which the cognizer doesn't know the identity. It's still an a posteriori factor whether gamma is alpha or beta, but still within each sort of kind of metaphysical partitions of alternative pictures of metaphysics, they still satisfy the necessity. So is that all right? Okay, then let's get to the last slide. So here's the original inference I was talking about. The cognizer is making an inference that, well, look, gamma is either alpha or beta, and gamma is not soluble. Therefore, if alpha is soluble, then beta must be gamma. Okay, so we can symbolize them as this, as before, and then this saying that the gamma gamma is not soluble, meaning that the gamma doesn't go to the asterisk. I mean, gamma doesn't disappear when you put it in the water in W3 or W4. And then the last bit is, therefore, if alpha is not, if alpha is soluble, you get a negation of alpha is not soluble, then beta must be gamma. Okay, so this is the formalization of the original inference in the intentional logic that I was talking about. So it's good. Okay, so now my claim, my original thing that I mentioned is that, look, this is an invalid inference because there's a counter model. Look, here, for instance, in this picture, even though W1 has green and red coinciding and the blue is the different thing, red is soluble, even though gamma is not soluble, because if you go to the W3, then gamma goes to a existing thing and the red goes to non-existing thing. So this is a counter model to the inference that seemed like just a valid inference in first order language. Okay, so that's good. So, so now let me ask you, what would you be a way out if you want to make this inference? If you want to let this inference go, what another like premise would you add to the picture? Sorry, for the sake of time, let me just give the answer myself. So the answer is this. One answer, it's not the answer, but one answer is that, look, let's assume that the cognizer knows that is crystal is an absolute notion, and by alpha and beta gamma, the cognizer knows that alpha beta gamma are crystals in the absolute sense. If you add this assumption on top of the picture, on top of these, in addition to the assumptions premises 1 and 2, then yes, this assumption rules out this this model, and we end up with this model that says that, look, yes, now the cognizer knows that if red goes to asterisk, then the blue must be identical with the green. Okay, so the upshot of this example is this. Look, so in a way, this is to assume that, look, this assumption 0, this premise 0 I propose is essentially to assume that, look, the cognizer believes in, uses Kripke's metaphysical theory, basically, or maybe so, or maybe like the counterpart idea of a crystal as a sortal. But either way, this cognizer uses kind of metaphysical principle that Kripke claims that an ordinary folks have, and this intentional logic makes clear that this sort of the ordinary folks metaphysical principle must be there for even such an elementary inference to go. So let me first conclude this part and the talk. So the upshot is that our intentional logic has such a strong expressive power that those metaphysical properties or properties like absoluteness can be expressed in this logic, and therefore we can axiomatize other quantified modal logics by Kripke or Lewis or Grafara as theories within this logic. And then that means that that's something even cognizers can use or learn inside this logic. Okay, because that's a theory in logic, and so that's a fair game for those cognizers to start without believing it, and then come to know that or refute it. Okay, so the conclusion of the entire talk is that it's kind of a stupid picture. Okay, so I wanted to model a posteriority of the necessary a posteriori. So the first half of the talk was to give a general semantic framework. So we needed a generality, but that was not satisfactory enough. So I wanted a expressive power too, so that we could have kind of a regain a logic theory distinction even inside a modal logic, and then that explains a posteriority of necessary a posteriori. But on the other hand, I mean, in such a way that logical roles of metaphysical theories in modal reasoning can be explained inside this picture, so that we have a more complete explanation or account of a posteriority of the necessary a posteriori. So that's it. Thank you.